So hello everyone, welcome here, and today we will discuss about the algorithm, what is the meaning of algorithm and analysis of algorithm also, and types of algorithm, and after that we will see the graph of algorithms and execution time. We will see also the execution time of our algorithm, and after that we will also see that worst case means type of execution times. Okay, execution times types. Okay, worst case, and after that we will discuss about best case and what is the average case. Okay, so first of all we are going to discuss about algorithm. What is an algorithm? An algorithm is nothing but just like a protocol, means a rule to solve any problem step by step, that is called algorithm, but should be infinite time. Infinite means it will be finite. Okay, so what is the meaning of algorithm? Algorithm is nothing but a way to solve any problem line by line, step by step, that will be called algorithm. Okay, so if you are going to do any solve any problem, at that time you will step by step solve your problem, then it will be called algorithm. Okay, so here we are going to see that analysis of algorithm. For solving a problem we have three algorithm: a1, a2 and a3. Suppose we have three algorithm, that is a1, a2 and a3, and a1 is taking 0.5 second, a2 is taking 0.5 microsecond, and a3 is taking 0.5 millisecond. Then what will be happen here? Now we have the we have to decide which algorithm is best. That's the reason we have to analysis the algorithm on the basis of time and space complexity. What is the meaning of here? Algorithm, we will analysis the algorithm with the two bases, that is one is space complexity and second one is time. So we will see that which algorithm is based in space complexity and time. Okay, so here we are going to see that our first algorithm is taking 0.5 seconds, second one is taking 0.5 microsecond, and a3 is taking 0.5 milliseconds. So here a2 is very efficient for time and space complexity, so it is the best for our algorithm analysis. Okay, so we will choose this algorithm a2. Okay, therefore a2 is the best algorithm, therefore a2 is the best algorithm here. Okay, mostly algorithm analysis in prior or posterior. Means posterior means what? Posterior means by machine, means what? Execution time by machine, that is called posterior. Solve any problem by machine, that is posterior. Execution time, it will be give the execution time, that will be called posterior. If you are guessing, if we are guessing the execution time, that is called prior. Okay, so here we will discuss about what things, that is prior analysis and posterior analysis. So prior analysis what is the meaning of prior analysis? So by human, if you are guessing the execution time, that will be called an analysis, prior analysis. Okay, prior analysis we do as a programmer before submitting the task to the hardware. That means completely independent from the hardware. That's the reason it gives a prox result. Means in prior analysis, as a programmer will guess the execution time to the help of input numbers and input numbers in our function, in our program. Okay, so before submitting the task to the hardware we will guessing, and that means completely independent to the independent from the hardware devices. That's the reason, means CPU no dependent here to the CPU. Okay, we will guess as a programmer. That's the reason it gives approximate results. Okay, so not it will be exact value, but it will be approx results. We can only approximate results we can give. The execution time with the help of execution time with the help of our inputs of instructions, number of instruction, etc. Analysis, after analysis we can give the result approximum, not exact, but maybe sometimes we can give the exact times. Okay, exact value result. And what is the meaning of posterior? So what is posterior? Posterior is nothing but by machine. Okay, means execution by machine. Machine will be exact time, give the exact time, that will be called posterior. In this analysis we mostly focus on the exact time of execution of our program. That means this analysis completely depend on the hardware, depend to the processor's speeds. Okay, so posterior means what? Means any programmer is not guessing the execution time with the space complexity or time complexity. So our hardware, means our CPU will be decide, then it will be called posterior analysis. Our hardware is analysis the of our program, that will be called posterior analysis. Okay, and after that we are going to see that here we have a just like a query that find the approximate execution time by programmer. Means find the approximum execution time by programmer. Number of program, means input, is equal to program's execution times. Means means a programmer, means I want to say you that a programmer can give execution time with the basis of number of program, means input. Okay, so here we are going to say about this. Okay, and after that here we are going to focus number of inputs in our program, because only programmer can give the output approximate result with the help of inputs numbers in our program. And also it is also depend it is also depend to the hardware also. Means the hardware will also give the answer reciprocal to the our number of inputs, number of instruction to the our program. The means that means we completely focus on the number of statements for the execution by CPU, means central processing unit, means processor. Okay, as a programmer we first understand the magnitude means what? Execution time, read and write by CPU of a statement to find approximate execution time. Okay, so here we are going to see that CPU, if CPU will be if CPU will be analysis, then it will be called posterior. Okay, if our CPU, our hardware will be analysis our program, and then it will be give the result, then it will be called posterior analysis. Okay, and after that we are going to see here that another point is here annotation. What is the meaning of annotation? Representation means annotation also. Okay, of time complexity, represent of time complexity. This logic used to represent the time and the space complexity through symbol. Here we are going to to see the execution time of program to 2D graph. As we know that function execution time depends on the numbers of inputs, that is function of n, f of n, mean number of inputs, number of number of instruction is reciprocal to the our time, okay, execution time. So here we are going to see that if any instruction will be execute, then it will be take the constant time in our function or any in our program, okay. And after that we are going to see here that graph. Here is a graph that is a linear graph. Here we are going to give the inputs. If input will be increased, then time will be also increased, then it will be called linear graph, okay. So with the help of this picture you can easily understand about this funda. And time complexity categorized in mostly three cases. That is, one is here, one is worst case, second one is best case, and third one is average case, okay. So execution time is divided into three times: worst time and best time and average case. So first of all we are going to see that worst case is denoted by big O and time, that is also called constant time. And best time is here by omega. Omega is here, omega symbol is here, omega symbol and time. And average case equals to maximum plus minimum by 2, means it will be denoted by theta. As a programmer, always focus on worst case, because whatever time will be take by any processor more and more, then it is compatible for our program. Means here we are going to see that this line is just saying that that we are, any program, if we are going to analysis any program, at that time we will take the worst time, because if any program will be take the more than time, then it will be take the time below that our worst time, okay, below or equals to that the we every time we use we every time remember this worst time, okay. So worst case always denote the upper bound of graph of function. Worst case always denote the upper bound. Here our upper bound, that is denoted by g of n and graph of function, and f of n is denoted by our inputs in our function, okay. And here you can see that equation is here. Our in, our input in our function maybe maybe less than or equal to g of n, okay, but not more than g of n. It may be below here, but below here, but not more than below 0, more than by 0, okay. Means it will be not come here, it will be not, means upper case is here and lower case is here, upper limit is here and lower limit is here, 0 to upper limit, okay. So what is this? It is just time and uh, instruction time and instructions numbers graph, that is here we are going to see is we are going to understand you with the help of this graph, curve graph, okay, curve graph. And after that we are going to see here that here we are going to see that graph analysis of time complexity in three cases. That is, we have already discussed about worst case, that is maximum time. Upper bound is here, and our number of inputs in a function is here. It will be not it will be never more than g of n, and it can't be below more than uh, this lower limits. Okay, so for this execution, it is the highest upper limits and it is lower limits. And after that, we are going to see that worst case always denote the upper bound of graph for worst case function. Means what? Worst case always denote the upper bound of graph. Worst case function for worst case of function. Here we are going to see that equation of our functions of our worst case. So function of inside our function, number of inputs is maybe less than and equal to, can less than equal to our upper limits. And here also we are going to denote it by worst case with the help of big O and big O and of Gn. Okay, and after we are going to see best case means maximum execution time, minimum execution time, because worst case means maximum execution time and best case means minimum execution time. Means lower bound is here, but here we are going to fix the lower bound here it is the lower bound, it will be lower bound, and it is the our function, and it is the upper bound, but it will be not it will be also for this upper bound, and this is lower bound, so it will be only here. Okay, execution time will be here only inside this. Okay, so here our equation is here. F of n is maybe can greater than equal to g of n. F of n, and we are going to you know that we are going to omega use for best case, so we are going to show you with the help of omega. Minimum time it will be so. Average space means average case. Okay, so here we have also three graphs. You see here in a 2D block axis, it helps to find exact time. G2 of n and G1 of n, means here our f of n will be only here and here, means it will be it can't more than g1 of n and can't below more than g2 of n. So it helps to find exact time g2 of n. G2 of n is here, maybe less than or equal to f of n, and f of n maybe less than equal to g of n, maybe less than and equal to, but not more than g1 of n. So here we have a equation of this average case. As we know that we are going to denote it by theta of our average case, function of n equals to theta and g1 of n, or theta g2 by g2 of n. What is here g1 of n and g2 of n? Lower and upper and lower. Okay, so it is all about our cases analysis with the help of analysis of time complexity. And here after that we are going to see here that time complexity analysis. Magnitude of a statement means execution time, read or write. We always focus on the magnitude of a statement, means what? By CPU execution time, means read and write time. That means how much time a statement is going to read and write by CPU. Okay, that is the meaning of magnitude. Suppose if we have a function that is a main function, and inside main function we have two statements, that is here. One statement is here, that is integer p. We are going to only declare variable, and here we have a second condition, that is statement is here. Okay, that is print. We are going to print the variables. So we have two instruction here. One is declare a variable. We are going to set to the our CPU that let's go and create a variable that name is p, and after that we are going to say that let's give the block address of p. Block about means here we are it will be give the garbage value, because if our block will be not full, then it will be collect the garbage value. Okay, so it will be give the output garbage value. So basically we have two statement here. So we have two as you know that one single statement for execution time take a constant time. Means what? Constant time, fixed time it will be take. So we have two instructions, so it will take two constant time. Okay, so here we can see that what is the meaning of magnitude and everything with the help of these codes. And here we can also see that we have one statement is here, and we are going to use a looping concept here. We are going to initialize the 0 to the I and to looping concept, and increment, and it will be check the condition. It will be loop will be start from the 0 and go to the 3. 0 1 2 3 means it will be four statement is here and 1 is here. Means here in this source code we have 5 statements. Okay, means 4 time it will be print and 1 time is here. So it will be also O of big O means constant time, worst case, and fourth is our execution time. Okay, constant. But suppose if we have no any destination, then what will happen? We will write in. We will suppose we will also then at that time our execution time will be big O of n. Okay, so it's all about these things, that's time complexity analysis. And what is a statement here? We have see you have seen today, and constant time means what? Fixed time, okay, by CPU, processor speed, okay. So it is what is the time complexity analysis today you have discussed. And average space means average case, best case and worst case. And also today you have discussed about execution time types, that is worst case, best case and average case. And after that, before that, we have also discussed about the linear graph in our program to the execution time and number of input. It will be depend to the our number of input on program. Reciprocal, it will be reciprocal to the our number of instructions in our program, okay. And today we have also discussed about what is algorithm, analysis of algorithm, rule of analysis of algorithm, and prior analysis and posterior analysis also, okay. So for this class we are going to close this class. After this class we will also discuss about the new topic in algorithm or any programming languages. So if you are getting all these points, you can subscribe this channel or bell icon for getting the new notifications always times. And if you are not getting any points, then you can give we can ask me a question with the help of description box. Then I will try to give you answer, okay. So let's bye.